Hello everyone, welcome to IGCSE Year 10 Physics. In this video, we're going to talk about specific latent heat. Under IGCSE Physics latent heat, the student have to know on how to define specific latent heat, mainly latent heat of vaporization as well as latent heat of fusion, and the student have to know on how to interpret in terms of molecular level for these two latent heat. Apart from that, the student also have to be able to describe experiment to measure specific latent heat for steam and for ice. Basically, for steam is latent heat of vaporization, for ice is latent heat of fusion. And under this latent heat, we have equation energy is equal to ml, and they have to be able to solve the questions based on this equation. Okay, let us look at what is latent heat actually. Okay, latent heat is the heat energy that is required for a substance to change state, either be it liquid to gas or solid to liquid. And when we supply energy during this period, the substance temperature remains the same. The substance temperature is constant. Because of that reason, we know this type of energy is hidden energy or latent heat. Okay, since the energy supply does not increase the substance temperature, that energy is actually needed to break the bond between the particles or the molecules. Okay, in this bulk down here, we have the definition on specific latent heat of vaporization as well as specific latent heat of fusion. Okay, the one that I underlined here, basically the keyword that the student have to have in writing down definition. Okay, the specific latent heat of vaporization is the energy that required to cause 1 kg of the substance to change state from liquid to gas at its boiling point. So the student have to remember here, when you have the word specific, you must state 1 kg of substance. And when you have the word vaporization, meaning it is liquid to gas. Basically, both of these definition, you just change the keyword. So for this one, from vaporization into fusion, and from liquid to gas into solid to liquid. Under this definition, the student have to know that vaporization, it means vaporize from liquid to gas. Fusion is melting process from solid to liquid. Okay, basically these are the two equations that the student have to know. E is equal to mLV, LV for latent heat of vaporization, and it is measured in joule per kg. Same as well for latent heat of fusion, E is equal to mLF. Okay, at the side here we have heating curve. So basically from solid, if we supply heat, the temperature keep increasing until one point here where the solid start to melt, and at this constant temperature, the solid melt turn to liquid, and right at this point, all the solid already melt. And at this constant temperature, there is latent heat of fusion is involved here. Same as here, latent heat of vaporization during the boiling process is involved during the change of state from liquid to gas. Okay, let us look at one example of calculation of specific heat, latent heat of fusion of ice. Okay, let's say we have this experiment and we have heater of 100 watt. It's being switched on for 300 seconds. Okay, by weighing the water collected in the beaker, it is found that 0.1 kg of ice has melted. From this figure, the value of L can be calculated. So this value of L here is actually for latent heat of fusion. So since we have power 100 watt time 300 second and mass is equal to 0.10 kg, so we can calculate the energy supply first, because inside latent heat equation we have E is equal to mL. So we don't have the information about energy, but then we have the information about power and time. So power times time is equal to energy, so it is equal to 30,000 joule. So we plug it into the equation. E is equal to mL. We want to look for L here, latent heat. So latent heat is equal to energy divided by mass. So energy divided by mass means the energy is 30,000 joule divided by 0.1 kg. We get 300,000 joule per kg. That is specific latent heat of fusion of ice. Same as well for latent heat of vaporization. Okay, this step is the same to get the specific latent heat of vaporization. So if you look at here, latent heat of vaporization is bigger compared to latent heat of fusion. So it means that we need more energy to change state of liquid for it to turn to gas compared to change state of solid for it to turn to liquid. With that, I thank you for watching.